All right, do we have any questions in the room? Yes, Adam.
So Brooke, when you showed just the last graph where you showed that kind of extended period of high chlorophyll, is how, I know you mentioned that you wanted to look at kind of longer time periods. Is that really a crazy event of that long of a time period where it was spiking, or is it possible there's some other factors that played into the die-off, or is that?
So I would think that undoubtedly there are other factors. So Adam is asking whether the event that led to this die-off, I think you're asking if it's really represented by that peak in chlorophyll? Is that?
Well, I was asking kind of if you went further back in time, say another year, does that kind of extended period spike happen often, or is it just that year it was crazy?
So we can't really directly compare. So Adam's asking whether or not that extended period that we see in the last graph, whether that persistent peak is something that's really an anomaly or really different for that area. And we can't really go back in time. So even though we have a continuous even though we have this continuous data for ocean color, we don't have the type of resolution that we get with VIIRS. So this, beginning in about mid-2013, is the best resolution that we have. So we can say it, as you put it, it's pretty crazy for that 4-year period. But if we look back further, we're looking at CWIFs and MODIS data, we're getting 4 and 9 kilometer values. This particular event was over about 250 meters. So it doesn't really give us much of a representation. This is the longest period that we have that we can compare that with.
Any other questions? Do we have any online? Oh, yes, Missy.
I have a question. So, when you were talking about doing your air sampling earlier and about trying to maintain the balloon within the plume the entire time, and that you didn't want to dilute your sample with background air by sampling outside of the plume, are you able to actually calculate the volume of plume that you're sampling so you actually have concentrations?
So the question was really related to the fundamental calculations of how we calculate the emissions in plumes. And basically we are not calculating the volume of the plume. We are using what's called the carbon balance method. And so while we are measuring all the volume that we sample, we're obviously sampling only a very small fraction of the whole plume. But what we're assuming is that the plume is perfectly mixed and that we are co-sampling the pollutant of interest. In that case, it was chlorinated dioxins and furans. We're co-sampling that with carbon monoxide and CO2. And so we take that carbon mass and we relate that, we call that the amount of oil that's burned. And so we have a ratio then of dioxins to carbon, which is the same thing as the ratio of dioxins to oil burns. And so there we have an emission factor, and that's how we do those calculations.
So, sorry, go ahead.
Dr. Bryan, appreciate it. Really good data, because we've looked at how in situ burning affects, the outer population, specifically PAHs and particulate matter. I guess I have a few questions. You may want to talk offline, but did you get enough data to help with any dispersion modeling to determine how far a safe distance would be from an actual burn?
So the question was related to whether we had sufficient data to do dispersion modeling regarding, I guess, inhalation toxicity. The answer is yes. In 2010, the emission factors that we used, at least specifically for the ones we determined, which were dioxins, they were put into some dispersion models. I think high split was one of them, and basically they were the impact, potential impact on inhalation exposure to local communities was calculated. But in all, the Deepwater Horizon and the in situ burns were so far offshore that it was really very difficult for even the shoreline monitoring to distinguish emissions from the burns versus a lot of the industrial sectors that are all up and down the coast. So basically, as far as I could tell, all the monitoring that EPA did along the coast, there was nothing that could be without doubt attributed to the in-situ burns.
Yeah, appreciate that. We're looking at more to the responders and then the other, you know, facilities offshore and the workers offshore too. So to tie into that, anybody on the vessel with the aerostat and any respirators or?
So, yeah, interestingly enough, before we were allowed to leave shore, we were required by somebody to have full-face escape packs. And yeah, so that was a last-minute gotcha. I don't know where that came from. Because I know everybody else was out there and nobody else had it. Yeah, and quite frankly, I don't know whether that was, well, I shouldn't even say my suspicion. This is my personal opinion. Is that edict came from probably my own agency is my guess, but I'm not positive about that. But so these escape packs are very expensive, and to get 20 or 25 of them for my crew, the crew on the vessel, the crew on the accompanying boat was nearly impossible. But I think it was BP that actually rallied up the money and flew in these escape packs from all over the country. And without their cooperation, we wouldn't have been out there. But I don't, you know, the plumes go up. So we actually had an industrial hygienist on the fantail of our ship, and he was monitoring air quality. And the only time he ever got a hit was when the cook was cooking steaks on the grill.
At least he noted that.
Yes.
Do you see additional sampling should there be another event which required in situ burning as a condition of approval, or just to gather more data?
I don't think EPA has any jurisdiction that far off shore, so I don't think there's any requirement for such a thing. Do I think there's more data? I mean, come on, I'm a researcher, so yeah, of course there's more data needed. No, actually, I would say that we don't have a lot of data. We've been able to supplement the data with onshore simulations, but how well that simulates what actually occurs out on the ocean, it's not really clear at this point.
Yes.
Yes, Brooke, regarding the information you gathered dealing with the river plumes, has any correlation been made with hypoxic zones with some of that data?
So the question is whether or not there's a correlation between river plume data and hypoxia. There is, obviously, the river plume, the Mississippi River plume is associated with the Louisiana dead zone. But as far as, I actually did some work on this myself, looking at whether or not changes in river discharge or something like that might affect hypoxic zones or might affect the volume or timing of hypoxia. And we really didn't find that it was as much related to something like the volume of river discharge as it was to the timing and physical environmental conditions at the time that there was a high period of discharge. So the actual change in volume didn't seem to be as important as what the stratification and other physical conditions were at the time.
Even mapping it as far as where its location?
Yeah, as far as mapping it, I didn't really look at that myself. I'm sure there is data on that, but I'm not familiar with it.
Do you have any other questions, Lily? Yes.
One more.
Go
On
for
the
it.
drones, the UAV. I've seen some projects and studies on that too. Did you have any concerns with the rotor wash affecting the representative change?
Yeah, the question was whether the rotor wash from a multi-copter drone would affect the emission measurements. Yeah, that's a question that always comes up. It's a good question. My opinion is that if you're measuring gases, absolutely no effect whatsoever, because the gases are just gases, and you're mixing gases and gases. If you're looking at particle size distributions, yeah, maybe one could make an argument that if you're using a impactor type device or something like that, that you're affecting the way it functions. But I have some evidence I have 3 different pieces of evidence that suggest otherwise, that there's really very little effect of the rotor wash on the measurements of particles, and that is because the particles from these combustion events are so small, sub-micrometer, that basically they are just sort of following the streamlines of the gases, and you have no sampling bias whatsoever. Still is an open question, but I'm relatively convinced that it's not a problem.
Thank you.
Any other questions in the room? No, well, again, let's thank our speakers.